All right, everyone, the question says, find the mass of unreacted starting material when 75.0 grams of sulfuric acid reacts with 55.0 grams of calcium hydroxide. So the problem is giving us the masses of both of our reactants. It gives us 75.0 grams of sulfuric acid, which is H2SO4. So we have 75.0 grams of that. And it gives us 55.0 grams of calcium hydroxide, which is CaOH2. And we have 55 grams of that. And the problem is asking for the mass of unreacted starting material. So basically, after this chemical reaction would go to completion, one of our reactants will be left over and the other one will be completely used up. So we're trying to figure out how much of the one that has excess left over is still there. So we're going to have to do some stochiometry. There's a couple ways to do this problem. One way is to take one mass of your reactant and calculate how much of the other reactant will react with it. So let's take just the 75.0 grams of H2SO4 and let's see how much CaOH2 will react with it, and then we're going to compare that number to the 55.0 grams that we have given to us from the problem. Okay, so let's do the stochiometry. So we're going to start with 75.0 grams of H2SO4, and we're going to calculate how many grams of CaOH2 would react with it. So since we're going a mass of one substance to mass of another, that is going to be 3 conversion factors, 3 fractions. Okay, so we'll set those up there. For the first step, since we're starting with grams of H2SO4, we're going to put that on the bottom. So grams of H2SO4. Okay, that goes on the bottom of our first conversion factor so that it will cancel out, and we can go from grams to moles of H2SO4. And for that, we need the molar mass of H2SO4. So to calculate the molar mass of H2SO4, we're going to need to multiply 2 times the molar mass of hydrogen, okay, because it's H2, plus 1 sulfur, plus 4 times the molar mass of oxygen, because it's H2SO4. So 2 times the molar mass of hydrogen, well, looking at the periodic table, hydrogen is 1.01 grams per mole, plus the molar mass of sulfur is 32.07 grams per mole, plus 4 times the molar mass of oxygen, which is 16.00 grams per mole. Punch that in your calculator, hit equals, and we get that the molar mass of H2SO4 is 98.09 grams per mole, or for every 1 mole. So that is what we put into our first conversion factor, where we're going to flip it and have 1 mole on top and 98.09 grams on the bottom. And that will make it so that our grams of H2SO4 will cancel in our stochiometry. And then we can move on to the second conversion factor, which is our mole ratios. In our chemical equation, we have 1 H2SO4 because nothing's written there. We imply that it's a 1. And then we also have 1 calcium hydroxide because there's also nothing written there. So it's a 1-to-1 ratio. For every 1 mole of H2SO4, it's going to react with 1 mole of calcium hydroxide. So we can put 1 mole of H2SO4 on the bottom and 1 mole of CaOH2 on top. And that mole ratio will allow moles of H2SO4 to cancel, and we are left with moles of CaOH2, which we can take those moles of CaOH2 and turn them into mass of CaOH2. So we need the molar mass of calcium hydroxide. So the molar mass of calcium hydroxide will be the molar mass of calcium, so Ca, plus 2 times the molar mass of oxygen and 2 times the molar mass of hydrogen. And why it's 2 for both is because it's OH in parentheses and then a 2 after. So this 2 applies to the H, and it also applies to the O. So molar mass of calcium, looking at the periodic table, is 40.08 grams per mole, plus 2 times the molar mass of oxygen, we already looked up, was 16.00. And then also 2 times the molar mass of hydrogen, which again is 1.01 grams per mole. Plug that in your calculator, hit equals, and we get that the molar mass of calcium hydroxide is 74.10 grams per mole. So that is what we will use in our final conversion factor, where 74.10 grams goes on top and 1 mole goes on the bottom. Our units of moles of calcium hydroxide cancel, and we are left with the exact unit we want, which is grams of calcium hydroxide. So now we can plug this in our calculator and see what we get. So we're going to start with our 75.0 grams, and we are going to multiply by the top and divide by the bottom of each conversion factor, ignoring anything that's a 1. So we're going to divide by 98.09, skipping the second conversion factor because it's 1 on top and 1 on bottom, and then multiplying by 74.1, hit equals, and our calculator says 56.65 and some change. Let's round that to 56.7. So for the stoichiometry on the first problem, we get 56.7 grams of calcium hydroxide, and that's how much would react with our 75.0 grams of sulfuric acid. So now let's look. The problem says we have 55.0 grams of CaOH2, okay, 55.0 grams. That is less than the 56.7 grams of calcium hydroxide that we calculated would react with the 75 grams of sulfuric acid. So what that tells us is that calcium hydroxide is our limiting reactant. All of the 55 grams that we were given is going to react because we need 56.7, and we don't have that much. We have less than that. So if calcium hydroxide is our limiting reactant, sulfuric acid is our excess reactant. So that means there's going to be some left over. So because we did the stoichiometry based off our excess reactant, we need to do it again now based off the limiting reactant. That will tell us how much sulfuric acid will actually react, and then we can subtract that from how much we have. So now we need to take our 55.0 grams of calcium hydroxide, and we need to turn that into mass of sulfuric acid. And we're going to do that exactly like we did above, except we are going to flip the order of our conversion factors, and we're going to flip them so the bottom becomes the top and the top becomes the bottom. So we're going mass of one reactant to mass of another. So it's again 3 steps. And then we're flipping the order and flipping the top to the bottom. So our first step is going to be converting grams of CaOH2 to moles of CaOH2, which is this step right here, the third step from above, but then also flipped. So 74.10 grams is on the bottom and 1 mole is on top. And we did that so that grams of calcium hydroxide will cancel. Our middle step here is also the middle step from above, but flipped. So we will have 1 mole of CaOH2 on the bottom and 1 mole of H2SO4 on top. And we're doing that so that our moles of CaOH2 cancels. And then our third step here will be our first step from above, but flipped. So we have moles of H2SO4 on the bottom and grams of H2SO4 on top, where 1 mole is equal to 98.09 grams. And our units of moles of H2SO4 cancel, leaving us with exactly what we want, grams of H2SO4. So we can plug this in our calculator now. We're going to start with 55.0 and then divide by 74.1 and multiply by 98.09. Hit equals, in our calculator says 72.80 and some change. Let's round that to 72.8. So 72.8 grams for our second stoichiometry problem. And what that is saying is 72.8 grams of H2SO4 would react with 55 grams of calcium hydroxide. Now we have 75 grams of H2SO4 that we were given in the problem. So if we subtract the 72.8 grams of sulfuric acid that will actually react, we will get how much is left over or unreacted. So this is how much we have, 75 grams. This is how much will react. If we subtract those, we will get how much is left over. So 75.0 minus 72.8 gives us a mass of 2.2 grams of H2SO4 that is left over. So we did 2 stoichiometry problems here. We started with 75.0 grams of H2SO4, which ended up being our excess reactant. If we would have started by chance with 55.0 grams, which was our limiting reactant, calcium hydroxide, we would have figured out first that 72.8 grams of sulfuric acid would react with it and see, oh, we have 75, that's more, so then we could do the math and get our final answer there. By chance, we picked the excess reactant first, so we had to do a little bit more work. But knowing that from now on, depending on which one you pick, you might not have to do this much. Okay, so final answer. Find the mass of unreacted starting material when 75.0 grams of sulfuric acid reacts with 55.0 grams calcium hydroxide. We will have 2.2 grams H2SO4 left over. All right, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.